My name is Matthias. My colleague Piero is here with me today. As Matt said, we would like to pitch you water-free glass, which is exactly what we do. The reason why we do this because glass is an extremely ubiquitous material. It gives us view, it gives us daylight, it's transparent, it's usually invisible. But because of this reason, we are actually not aware how much it impacts our built environment. It's responsible for a big chunk of the energy consumption in buildings. So if we would be able to improve them, we could save so much CO2 that is equal to double of aviation or all the carbon impact of all cars, or double of all the waste generation, carbon impact of waste in the world. And there is a couple of reasons why we're not doing this, and that is the problem that we would like to solve and talk to you about today. So glass is responsible about 25–40% of your energy bill, even in a typical building where windows are small. But we are not, so if you could replace your window to a better window, you could actually save a lot of carbon. But we are not doing it because it's a very messy process. It's really expensive. Obviously, the better window you get, the pricier it is. But that's just where your costs start. You have to have access from the outside, break the facade. You have to get permits. You need scaffolding of the building height. There's a lot of issues there. The bigger your building, the bigger your problem is, the bigger your headaches that you have to face. And so in the end, you just buy solar panels, as exactly as Matt put it, because it will save you less carbon, but it's just much less hassle. It has a lot of problems that people don't necessarily associate with glass, for example. So for example, overheating is reason of glass. It's not reason of the rest of the building. And obviously cooling down the building is also affects a lot. So it really drives your energy bills and your thermal comfort. What the industry does right now is, to put it very simple, is either they put some coating on the glass or they use more glass paints. We don't do those because they make glass products very expensive, and they don't perform as well. That will be proportional to the cost, so the payback doesn't come down. So as a reason, people are just not interested to go with them. But we have to address windows. There is no chance that they are responsible for such a high part of the CO2 emissions in the world that there is no chance that we're going to meet our climate targets if we don't do something. So we use water. One reason is because water is a natural material. So the carbon of producing a water-free glass is almost the same as producing a double glass or a triple glass. Unlike coatings, which have increased the carbon content by 28 times. Sorry. So it's a natural solution, and it also works differently. So put it simple, water absorbs instead of insulates. So in the summer, it blocks the sun to come in. In the winter, it blocks the heat to escape. So in that sense, it is really simple, and it saves a lot of energy, much more than a typical technology can. So for example, you can save up to between 45–75% of energy compared to a double glass, depending where you are. It works in all climates where you have buildings.
It's very easy.
It's very easy to scale and to build. We took about £1 million in grants total to address risks, to make it work. We have granted patents that work, already granted and work. It is cheaper, it saves more energy. It's a licensing system. So we sell license to glass factories and construction companies, so we have no limit to scale. And we have a lot of legislation that actually backs our to grow. Local Law 97 in New York is one. And we already have traction in companies that we work with across the world, describing license fees. We have projects in pipeline. And finally, this is our team that comes from sales to finance and technical experts. And we're fortunate to work with large partners among the biggest glass producers in the world to make sure that the company can grow. Why are we better? Why are we more competitive than?
Time is up.
any other
How
project.
much are you raising? Why are you better?
We are better because water-free glass you can put inside inside of the window. You don't need to remove the window, the existing window. You can just put our product behind, so you escape all these issues that you have, all the headaches you need. And we are raising $500,000 for currently to extend our team and expand our presence in the market.
Take it away. Alan's got big questions, I hear.
Well, like I'm looking at my window in front of me here, and my window serves purposes around structure in my office, around energy, but because I want to look through it. So what does filling my double lens, or what is the lensing effect? What's the distortion potential if I fill my glass windows with water and I'm trying to look through them?
Absolutely nothing. So the photo behind me is one of the buildings that we built. The water layer is very thin, typically like 15 mil. So it's absolutely no impact. You can't tell. If it's water in it. So we can simply show you photographs where we have the doors, for example, that are normal glass, and you have water-free glass that are fixed, and you can't tell the difference.
Okay, cool. So, yeah, I get when we double glaze and triple glaze and we want to put layers between the panes of glass in order to have energy insulation. I get the logic, but I've never considered that it wouldn't have a distortion. It wouldn't have a lensing effect. I wouldn't be able to notice that I've got water in between my panes. If it's demonstrably true that it isn't, then it's clearly a strong insulator. So happy days.
Yeah.
15 mils of water. So you don't have any prism effects. You don't have any element of light being split coming through or happening, any effects inside?
No, because water is the perfect coating. So it has a massive absorption, but the most of it works in the invisible spectrum of radiation. So like I always use the example like birds or snakes that have a different spectrum of vision than we do. They would see the difference, but we wouldn't. So that's what it makes it the perfect coating, because it absorbs energy in the spectrum where we cannot see it. And in that spectrum, it absorbs really well. So like if you Google radiation absorption of water, like Wikipedia, you will see the absorption coefficient. I'm sorry to go science, but you will see a graph where in the visible spectrum, it drops down. It's almost nothing. And in the invisible spectrum, it would go up.
I think the question that I'm throwing around in my mind is I think you'll say is dealt with by the fact that it's a 15 mil layer of water, where if it's anything thicker, it's literally like looking into a fish tank and it's going to have a distortion effect. So then if it is a 15 mil layer of water, what is the energy performance compared to double glazing or triple glazing with air or vacuum?
Yeah, the energy consumption of the space would drop about 45 to, if it's fully glazed, the energy consumption of the space would drop between 55 55 and 75 if it's a double glass, and between 45 to 65 it's a triple glass window. This would be in comparison with a standard industrial standard window, so like a DIN 700 typical. So that will be like a low coating, double glazed argon window, so not a single plane or something, because that would be not fair. Those are really bad.
No. So you're saying you're about equivalent to a good industry standard triple glaze. No, you're about 40 to 50% better than that again.
Yeah.
Pierre,
even the advanced windows like electrochromic, smart glass, we save more energy than those without any visual impact. You can actually, the space behind me, it was built in Taiwan. Solar gain is massively high. So if you look at buildings around there, it's complete standard to have black windows, black glass, because the sun is really strong, like you would see in buildings in Dubai. So we literally use clear glass on the building with zero shading to show them that the absorption works so well that you don't even need shading to keep the space cool. It works so well. So that's one of the strongest selling points. Like imagine, like, I don't know, you have an office or restaurant with a view, and you have to shade it for quite a big part of the year to avoid overheating. in our case, this problem doesn't exist.
Cool.
What if a window breaks? Just baseball, football, soccer.
Yes. We have a detailed technical solution so that these buildings, the prototype buildings, went through monitoring. So that's what partially the scientific grants were for. We use off-shelf products. So for example, water monitoring system that monitors the pressure. If the pressure goes down even slightly in one of the windows, it gets isolated automatically with the valves. So you only lose the water that is in that window. So that's controllable, and then you can replace that window or repair it, and turn the system on again. You can also isolate the window, so if it takes time to repair, that's no problem either.
It seems like a no-brainer and too good to be true. So where's the challenges?
The challenge is that you'd have to engineering community is conservative, and people are trained. Like myself, I'm an architect by training. One thing the engineers will always tell you, that one thing that we always trained to think of is to keep water out of the building as much as possible, because it's your enemy. So this is a mad idea. Even if the numbers are great, people respond. There is an unconscious bias, if you will, against doing something like this. So we currently have to focus on the innovators that are actually want to produce this product. So that's the challenge right now. But I think once those first projects are cleared, I'm hoping that the market will respond positively. But it is a no-brainer, especially for cities like New York, where you have the local law 97, because there's a carbon tax that's gonna kick in. I think it's 25, and it will quickly steep in 2030. So either with tall buildings where you have floor height at least four levels, 4 stories, and you have like 40% of your facade is glass, you can't really escape the tax or lower your energy consumption without doing something with your windows, because you can't put enough solar panels on your roof to make a difference, and insulation with that percentage won't do much good for you. So you have to do something with the window. And what they do right now is to put scaffold around the whole buildings, take the existing window out, put a new one in. It's insane. And in this case, you put something behind, and the job is done. So it's pretty much a no-brainer.
So water freezes, especially in New York. How do you guys deal with that?
Yeah, we got that question a lot, and it's perfectly valid. We have, again, an off-shelf monitoring system that works in multiple stages. So these are the systems that actually were developed for sprinklers, and also used in New York. So the freezing in those systems are the same problem. So we use the same system. We have the same warranties from those suppliers. Technically, because we come with an external insulation. So, for example, in New York, we would typically sell, if it's a new build, we would sell a triple pane glass with an external insulation, so that protects the window. If it's a retrofit, we keep the existing window and we put ours in as a double pane glass, and we have a small vacuum in between. So we improve the U value, the insulation value, which again protects the window. So in a normal operation, because for example in New York, even if the office is vacated, you don't go out below a certain temperature, because you make sure that the pipes don't freeze and everything, and that's perfect for us as well. And if that system doesn't work for any reason, then this alarm system kicks off, which case an off-shelf system that we have that monitors the pipes opens the system, and the whole thing is going to the pipes and to the sewers. So we release the water, because we don't use polluted water. We use clean water for our system, so we're not polluting the environment with this technology. So in that case, we could easily just remove it to the sewers, if that makes sense. And that's gravitating, it's physical process, so there is no risk in not getting the water out. And once things go back to normal, we can we can come back and fill back the panels. And it's usually for a building, it would be a 1-day job.
What geographies can you actually operate in then, where I mean, New York's probably freezing on like a several time a week basis at the very least. So is this just something where there's no insulation over the winter?
It's a really good question. So New York, for example, is really perfect for us because the operation does not necessarily come down just from temperature. It's also about solar gain and the amount of glass on the space. So for example, New York is a really good place for us because during winter, they have a really high solar gain that we can capitalize on. Technically, the technology, we built prototypes in different climates, but we ran, obviously we have, I didn't go into this, but because of the scientific grants that we won and the industrial grants that we won, we published a lot of peer review publications on top of our panels to publish the results and the math and the science behind it. We have those on our website. Basically, we tested in all major inhabited climates the technology, and it works and performs well in all climates, except the only exception is severely cold climates. So that would be, sorry for the science, it would be Köppen-Geiger climate area E, which is high mountains, north area of Canada, and this kind of places where you would normally don't have cities. But in the rest of the world, it works. And it saves energy.
And you mentioned about the pricing that is cheaper than conventional glass. Could you tell us a little bit more about your pricing strategy and how much it costs to produce?
Absolutely. There are different prices for the new build and for the retrofit, because we use different number of glass panes, and there are different costs associated with the construction project. To put it very short and simple, with the new build projects, our price currently, our market price is similar to our competition, electrochromic glazing. The reason why we can do that, obviously, because we don't have high manufacturing costs that they have, because we don't have expensive coatings. So in that case, we keep our pricing level to their level. In case of the retrofits, our pricing is actually cheaper than any other retrofit projects at the moment because we don't have the auxiliary cost. So scaffolding, removing the demolishment of the existing glass, managing the waste, getting the paperwork and permits and so on comes to a large part of the auxiliary cost actually of a project like this, especially for bigger buildings. It can go up to 30%, and for us that's a zero. So we're only competing with the rest of their contract. So actually, even with our good profit margin, which we can discuss in a one-to-one, which is good, it's better than normal glass manufacturers on normal glass products because we developed the pricing quote with them. And obviously they wanted to be motivated, so they wanted to have a higher profit margin for this product than the others that they're selling. And it's about double. And even with that, we can sell the product on a lower price than our current competition because killing the auxiliary costs. I hope that makes sense.
Yeah, that makes a lot of sense. And so you all are sort of past your R&D process. You're out in the market selling now, and you have customers.
Yeah. We just started. We are at the beginning of our selling phase. We have already some projects in the pipeline, and these are at the moment new build projects. So we are waiting. The projects has been started construction, but we are waiting for them to get to the point to put the window in, which is like usually for the 11th hour of the project. But yes, we are having already active projects that we are working on.
Where?
There is one project in United States. It's residential development, and then we have other projects currently in Hungary and Central East European area. So these are the places where we did actively do some sales efforts for now.
I think that mostly covers it for me. Alan, Stephanie?
Yeah, that covers it for me as well.
Sorry, I was on mute. Yeah, I'm good as well. Thanks for the presentation, Matthias.
Thank you. It may be helpful to know a little bit about how it works with the mechanical systems and everything. That's what people often ask as well. The strategy for the whole thing is that we use off-shelf in everything that we can, because we worked very closely with facade builders, facade profile producers, glass manufacturers, construction companies. And of course, we spend a lot of time and a great deal to build on their feedback to make sure that they're comfortable, because they are our licensed partners, right? So we want to make sure that they want to do this. And that because of that, really all the mechanical systems and everything that we do is off shelf. So for example, the piping we use is same type of pipes that you use in floor heating. So you get warranty on that. The water system filtering we use that protects us from algae is a technology that's already invented. What we invented is which protects us from being copied is the spacer system that we designed, our patents, and the science behind it that we developed for a longer term. So that was kind of something that gives us a convenient advantage, but also it puts us in a good position for collaboration. So when I call a glass factory to pitch the technology for potential licensing, one of the first things I immediately tell the person, like, if you produced double glass or triple glass, or you're producing right now, you can do this. You don't need to buy a new machine. You don't need to buy a new factory. And that's where they really start to go into the conversation, because glass factories are super expensive. So that actually gives us another important element, that we are operating in the construction sector where revenues are, the market is really big, of course. But we don't deal, because we are not project managers, we don't need to worry about the potential to grow. And because our product can be produced anywhere with existing glass factories, we have no limits to scale. We can scale very quickly. So we wanted to unite the best of both worlds. And we feel that we succeeded it, and our license agreements prove this, which is great. And this is really important, because if you think of our competition, for example, electrochromic glass, so Sage Glass is the oldest, and it's a great product, but they're producing it in one factory for the whole world in the last, I think, 5-7 years, because you need to reach a scale to build another glass factory, and these factories are really expensive. We don't have that problem. So that gives us a really nice opportunity, I think, for the startup. I don't know, Piero, did I miss something? Sorry, I feel bad for you. You didn't get any chance to say anything.
No, I hope that you covered everything, Matthias. I mean, I was the first investor in the business, and it took me a while to wrap my head around it. I have to say, the idea of putting water in glass and all the problems that you get from it jumped out to start with. I just had to think about it for quite a bit more and look at the way these guys have spent years and years perfecting a product. So it's unusual for me as an investor to get an opportunity to get in at this point where you've got developed technology, you've got patents, you've got some interesting projects in the pipeline, and a technology that solves issues, in a way that I don't think there's anything else quite out there that's doing that. I mean, for me, I bought a heat pump recently. It's probably, I equate it to kind of being a little bit like that, where there's a lot of fears about how the engineering is going to work. Does the technology work? I had it put in a year ago, and I've had zero problems. And I've to be honest, I forgot I had it done. But I think the hill to get over with this is kind of similar. You need to get the technology out there, get a few products done, get the right builders, and once it's out there and people see that it works, I think extremely compelling in terms of the carbon savings, the cost savings you can make, and the ability to scale. So that's why I kind of wanted to get on board this, and I'm pretty excited about what the company can do.
And I really sympathize that it does sound a mad idea. For our defense, we publish our science and the solutions in the best journals, academic journals in the world, peer-reviewed journals. And with the grants we work on, for example, the Horizon 2020 grant that we did, it brings in, we worked with glass factories that not only, they didn't just grab the money to do something, this is actually comes with levels of sales commitment for them. So we went through a very thorough due diligence process with this crazy idea with them, for example, before they committed. And of course, we wouldn't wouldn't have been possible if it wouldn't have made sense to them, and I wouldn't have done it otherwise, because there's no point doing if it's just a crazy idea. I hope that makes sense. I'm sorry, I recognize that it doesn't have much to do with food, and I'm sorry about that, but I think one element that may be interesting for you, Stephanie, is that we are working in additional products on the back of this. So currently we're focusing on the retrofit angle of it and the new build, simply because the market is really massively changing in the coming years. I mentioned New York, but I could have mentioned UK for the Energy Act 2011, where all properties need to go to energy level B by 2030 in order to be permitted to let, which affects 25% of all properties in the UK now, so they all need to be retrofitted by 2030. I could have mentioned the ETS, the energy emissions trading system of the European Union, which will be extended to buildings by 25 or 26, which is going to be a massive market for us. This is why we're doing it, but actually there are two other products that we want to go from here to agriculture as soon as possible, partially with this investment round. One is
and thanks for sharing. We kind of went way over the 5-minute pitching. We went through that a couple times,